Hi guys, my name is Minhajuddin Ansari and you're watching the 24th tutorial on C programming, and today we will continue our discussion on pointer arithmetic. So first of all, I'm going to define my integer array num, and it's going to be of size 3, and I'm going to initialize it to 1, 2 and 3. I'm also going to define my integer pointer star ptr, and it's going to store the address of the first element of the array. So I'm going to assign it the name of the array, and you already know that the name of the array is a pointer variable that stores the address of the first element of the array. So I'm simply assigning the value of one pointer to another pointer. So now let me draw my main memory, and my main memory is simply a sequence of bytes, and I'm going to represent bytes by small boxes. And I already talked about this in my previous tutorial, so those of you who haven't watched my previous tutorial, watch that tutorial before you watch this tutorial. So each byte also has an address. So starting from 100, this has 101, 102, 103, 104, 105, 106, 107, 108, 109, 110, 111, and 112, and so on up till the size of the main memory. So now an integer element occupies 4 bytes inside the main memory, because in the C language, an integer is supposed to occupy 4 bytes. So let's just give 4 bytes to our first element, 1, 2, 3, 4, and this is our first element equal to 1. So 1 is stored right here. Similarly, our second element also occupies 4 bytes. So let's give it 4 bytes as well. 1, 2, 3, 4, and this is our second element, and it's stored right here. And our third element also occupies 4 bytes. They're all integer types. So our third element, which is 2, which is 3, is stored right here. So this is how an array is stored in the main memory. So now the pointer is pointing to the address of the first element of the array, and the address of the first element of the array is actually the address of the first byte of that integer element. So it is actually equal to 100. So pointer initially has the address 100. So pointer has the address of the first byte of the first element of the array stored inside it. So now if I added 2 to the pointer variable, suppose I did ptr is equal to ptr plus 2. So you already know that pointer arithmetic is different from regular arithmetic. So if you increase or decrease a pointer, it increases or decreases according to the size of the data type of the pointer. So since I'm increasing it by 2, I'm adding 2. So it will actually increment by 8 bytes, because an integer is of size 4 bytes. And since I'm increasing it by 2, so I'm actually increasing it by 2 times 4 is equal to 8 bytes. So the value of the pointer will increase by 8 bytes. So if the value of the pointer is initially 100, so after adding 8, it would become 108 right here. And 108 is actually the address of the third element of the array. So, I mean, you can add any constant you want, and you can traverse or reach anywhere in the array you want, any element of the array you want to reach. Similarly, if I subtract 2 from the pointer variable, so if my pointer variable had an address 108, so subtracting 2, that means subtracting 8 bytes, because integers of size 4 bytes, I will reach back to my initial starting address, which is the 100, which is the address of the first element of the array. So this is how you can add constants to pointers. So now let's talk about binary operators we can apply on pointers. So, I mean, you can subtract, add constants with pointers, but when both of your operands are pointers, then you can only apply the subtraction binary operator. So suppose I had two pointers ptr1 and ptr2. So the only operator I can apply when both of my operands are pointers is the subtraction operator. So I can subtract ptr2 from ptr1. I cannot add them, I cannot multiply them, and I cannot divide them. And I'm going to show you that in Visual Studio in my next tutorial. So suppose your pointer ptr2, it stored the address of the second element of your array, and ptr1 stored the address of the first element of your array, which is in fact also equal to num. but I've just made it more simpler by writing this. So now I can subtract PTR1 from PTR2. So if both of my operands are pointers, I can only subtract pointers. So subtracting PTR1 from PTR2, this will actually give me the value 1. And you might be confused. You might say, hey, PTR2, if it's the address of the second element of the array, it should be storing 104. And if PTR1 is the address of the first element of the array, it should be storing 100. So 104 minus 100 is equal to 4. Then why did you write 1 right here? Remember, this is pointer arithmetic. So simply when you subtract two pointers, it gives you the number of integers in between those pointers. It does not give you the size of those integers. It just tells you how much integers are present in between the two addresses. And in between 104 and 100, there's only one integer present. So that is why 104 minus 100 is equal to 4. But since 4 is the size of one integer element, so that is why 1 was the answer. Similarly, if PTR2 had the address of the third element in it, so when I would subtract PTR1 from PTR2, that would actually give me 2, because two integers are present between the addresses PTR1 and PTR2 if PTR2 has the address of the third element of the array. So this is the only binary operator you can apply when both of your operands are pointers. And now you can also apply relational and logical operators on pointers, but you have to make sure that the pointers are pointing to the address of elements in the same array. So you cannot randomly pick two pointers and apply relational and logical operators on them. Both pointers should be pointing to elements of the same array. So this is a precondition. So what I'm going to do is that my PTR1, my first pointer, will store the address of the first element of the array, and my second pointer, PTR2, will store the address of the second element of the array. So now PTR2 is greater than PTR1. And why? This is because this has to do with relative ordering. So this is not the actual value. The actual value is not being compared here. PTR2 has the address 104 and PTR1 has the address 100. So 104 is not being compared with 100 right here. Simply the ordering of the elements is being compared. And since PTR2 is pointing to the second element and PTR1 is pointing to the first element, so the second element is ahead of the first element in terms of indexing. That is why PTR2 is greater than PTR1. This has to do only with the ordering of elements in the array. It has nothing to do with comparison of the actual value of the addresses. So that is why this will return a true value, which is 1. But if I write a false condition, PTR2 is lesser than PTR1, this is going to give me a 0. Why? Because when you check the ordering, the second element is ahead of the first element. It is not behind the first element. That is why that condition will give a false value. Again, actual values of addresses are not being compared. Only the relative ordering of the elements in the array are being compared. Similarly, you can write PTR2 is greater or equal to PTR1. This will also evaluate to true. And you can also compare two pointers. So if I write PTR2 is equal to PTR1, this would mean that PTR1 and PTR2 both point to the same element. Both have the address of the same element, which is not true because PTR2 is actually storing the address of the third element. So this will evaluate to a 0. Similarly, if I wrote PTR2 is not equal to PTR1, this would evaluate to a true value 1 because PTR2 has the address of the third element and PTR1 has the address of the first element. So this is all it about relational and arithmetic operations on pointer variables. If you have any questions, please ask them in the comment section, and thanks for watching this video.